Okay, welcome back. So, when you have your note sheet in front of you, the first thing you're going to notice is this big gray box. This is key. These are the steps that you need to go through, and if you follow these steps step by step, you'll have graphed your quadratic equation correctly. So let's look at the steps before we start. Number one, make sure that the equation is written in standard form. If you've got this in standard form, it gives you a lot of information. Notice that this paper says y equals ax squared plus bx plus c. Remember, that's also the same as saying function of x equals ax squared plus bx plus c. Okay? Once you have it in standard form, you're ready for step two. Step two, find the vertex. And remember, the vertex point is always going to be written as a coordinate pair, x, y. So you've got two steps here. First, you need to find what your x value is. To find your x value, you set up this formula. X equals negative b divided by 2a. That will always give you your x value that you put into this ordered pair right here. Part B is to take that value that you get, plug it back into your original quadratic equation, and find out what your y value is. We did something very similar to this when we were graphing lines as well. Okay. Step three, draw the axis of symmetry through the vertex. So just straight through the vertex, you're going to follow that graphing line all the way through. Step four, use the value of c to identify your y-intercept. So the same way when we had the equation of a line, y equals mx plus b. Remember how b was your y-intercept? Well, look at now you've got y equals ax squared plus bx plus c. Remember that y-intercept is when x equals 0. So if x equaled 0 here, y would equal 0 plus 0, because anything times 0 is just 0, plus c. And so that's why that c is the value of your y-intercept. Okay. Step 5. Use symmetry from your y-intercept to go straight across the same distance over your axis of symmetry to find out that second point of your parabola. And then you just connect the dots. Okay, let's put this into practice. Okay, here's example 1. Step 1, put it in standard form. Well, y equals ax squared plus bx plus c. This is in standard form. Step 1, done. Step 2, find the vertex. So the first thing we have to do is find our value of x. We find our value of x by the formula negative b over 2a. Well, our b in this equation is a negative 4. So we've got negative 4 over 2a. And our a in this equation is a 1. Remember, when there's no coefficient there, we assume that it's a 1. Well, let's solve. A negative 4 means the opposite of negative 4, which is simply a positive 4. 2 times 1 is 2. So this means our x value is a 2. So we know one of the coordinates for our vertex. Now we take this x value and we plug it back into our original quadratic equation to find our y. So y equals x squared, which is 2 squared, minus 4 times x, our x is 2, plus 3. 2 squared is a 4, minus 4 times 2 is 8, plus 3. 4 minus 8 is a negative 4, plus 3, negative 1. So our y equals negative 1. 2, negative 1. That's where our vertex point is going to be. So we come over 2, down 1, There's your vertex. Now, based on the value of our A being positive, we know that the general format of this parabola is going to open upward like that, right? If it had been a negative x squared, then it would have opened downward and would have looked something more like that. So now our goal is to find out exactly what this parabola looks like. Step 3, draw the axis of symmetry through the vertex. Well, just follow this graph line straight up. There is your axis of symmetry right through that line. Step 4, use the value of C. Where's our C? Our C is right here. It's a positive 3. Use your value of C to identify the y-intercept. Well, that means that my y-intercept is along my y-axis, and we go up to 3. There's my y-intercept. Step 5, use symmetry, meaning one side's going to be equal to the other, to draw a second point. So this y-intercept is 2 spaces from the line of symmetry. Going across that line of symmetry, completely perpendicular, you're going to have another point 2 spaces away from the line of symmetry on the other side. Now you have your basis for drawing your parabola. It starts up high and it comes down and up. Do not make this a perfect V. It has a U type shape. It's kind of a pointed U. It's not a rounded U, but it's definitely not a that type of graph. This type of graph would be an absolute value graph. So a parabola definitely has a curvature to it a little bit. Okay. All right, let's try one more together, and then I'm going to have you try a couple on your own. Okay. So we want this in standard form. Standard forms, this says negative y minus 3x squared equals a negative 3. Well, we don't want a negative y. We need a positive y, right? So you could just add y to both sides. So now we would have negative 3x squared equals a negative 3 plus y. This is a y, not a 4. Okay? Well, we want y by itself. Y equals, right? So we've got to add 3 to both sides. So now we would have negative 3x squared plus 3 equals y. Okay, we're closer to that standard form. In fact, you can consider this standard form. You've got ax squared plus bx plus c equals y. You might not see the bx. Because it's not there, that means x is being multiplied by a 0, right? Because when we add 0 to anything, it's like you've done nothing, so you don't have to write it. So this is your standard form. Okay, step 1 done. Step 2, find your x and y for your vertex. X equals a negative b over 2a. Well, we just said b was 0. There is no such thing as a negative 0, but it's 0. 0 over 2 times a negative 3, because a is negative 3. This is 0 over 6. 0 divided by anything is simply 0. So we know that our x part of our vertex is 0. Now let's find our y. Well, negative 3 times 0 plus 3 equals y. I'm so sorry. I just got sideways there. So therefore, our 3 is our y value. So we go 0 and then up 3. Right there is going to be our vertex. Okay, so this looks a little different than our first example, doesn't it? We have our vertex on the y-intercept. So you can't keep going in exactly the same direction. So what we can do though is we can decide, is this going to open up or down? Remember, what is our value of a? Our value of a here is a -3. Since it's negative, we know this is going to open downward. The next thing we know is we know what the axis of symmetry is. So we know the axis of symmetry is going to go right down this y-axis, right like that. Now, the next thing we know is that this graph is on a coordinate plane. And this graph is visually showing us what the equation is equal to. So that means I can choose any x value and find my value for y the same way I did when my x was equal to 0 here. So let's do that. Again, just like when we were graphing lines, the easiest numbers to work with are 1 and -1. So that's what we're going to use. We want something on both sides of our axis of symmetry. So it doesn't matter what numbers as long as they're both sides of this axis of symmetry. Let's look at this. If we use a 1, -3 times 1 squared plus 3 equals y. 1 squared is 1 times -3 is a -3 plus 3 equals 0. So we know one point on our graph is a 1, 0. So we would put a point, I'm sorry, not there, sorry, that's a -1, 0, 1, 0. Now remember, we know because of symmetry, that means there does have to be a point over here, doesn't it? We could prove that to ourselves. Let's try it. -3 times -1 squared plus 3. Well, -1 squared is 1 times a -3. -3 plus 3. We've got that as 0. So here you now have your 3 points. You can graph your parabola. And it is ongoing forever and ever, so you want those tips to always have an arrow on it. Make sense? Here's your chance to try. I want you to pause this video right now, and I want you to try to graph this equation. I'll give you a spoiler alert. Step 1, done for you. Pause this video. I'll see you back in a moment. Okay, I'm assuming that you paused the video and you have your answer. I'm going to work this out for you now. So step 1's done. We need our coordinate pair for our vertex. So we say x equals a -b over 2a. Our b is 8, so -8. 2 times a, and our a is a 2. So this means that our x value is at -8 over 4, which is a -2. Now we use that to find what our y value is. Y equals 2 times -2 squared plus 8 times -2 plus 2. So -2 squared is a 4 times 2 is 8 plus 8 times -2 is a -16 plus 2. 8 plus -16 is a -8 plus 2 is -6. So -2, -6 is our vertex. 1, 2, 3, 4, 5, 6. That's going to be right here. We now use our C. Oh, almost forgot. Got to draw your axis of symmetry. We know that this parabola is going to open upward because A is positive. Now we use our value of C to find our y-intercept. Well, our value of C is a +2. So that means our y-intercept is going to be right here. You then go straight across your axis of symmetry to find your third point. We've got 2 spaces to our axis of symmetry. That means we're going to have 2 spaces from our axis of symmetry. And now you have everything you need to draw your parabola. Okay, I think you guys are ready. What you can do is you can leave now and you can go and work on your assignment, or you can pause this video, try the next 2 on your own, and then come back and you can just see the answers and I'll have them up for you. All right. Okay, so as you can see on this first problem, your vertex is a -2, 6. Because your A value is a negative value, it'll open down. If you missed putting this in standard form, you might want to come back on Zoom and get with me and figure out why I did it that way. We always want a positive Y. That's important. Then when I looked at my C value, it's a +2. And then I go straight across and I find the match to it and then graph it. On this one down here, you see that the vertex is a 2, -4. Because our A is positive, that means the parabola is going to open upward. We use our C value for our y-intercept, which is a +4, and then go straight across to find that third point and draw. So I'm hoping this is making sense to you. If it is, feel free, go on with your assignment. If it's not, come into Zoom. I'm there, ready to help you. Have a great day. I'll see you soon.